Welcome everybody to the first goat series. We've got a good goat herd here today. I'm Dorn Cox and one of the members of the Gathering for Open Ag Tech, and I'm here with Greg Austic, who's going to tell us a little bit about Our-Sci. But before we do that, I'm going to say a couple words about what GOAT is and what we're all about, and then we'll dive right in. So GOAT, or Gathering for Open Ag Tech, started as with a recognition that we're better at agriculture when we share our knowledge, and we started with a gathering of 60 data technologists, software developers, researchers, and farmers to launch this process. And we represented a whole suite of open agricultural tools, including farm operations, modeling, info, direct marketing, aggregation, planning. We recognize that as exciting and terrific as it is to all get together in person, it's also really important to further these activities in between our gatherings. And so thus the web series. So we're really happy to share that with you and dive in to continue these conversations. And with that, I will hand it off to Greg and Our-Sci to introduce the exciting work that he's doing.
All
Greg,
right.
take it away.
Okay. So let's just talk for a minute. So I'm Greg. So our company is called Our-Sci, and our goal is really to help communities who want to answer questions that require research level processes by providing them appropriate software and hardware and training. So that's kind of mushy until you hear an example or two. So that's what I'm really going to focus on, is just walking through like 2 examples, and hopefully that gives you some context for what we're doing, and kind of walk you around the lab for some bits of that. And then at the end, we'll dive into, I think, what makes this a particularly, or what we hope makes it a good open ag tech project, in that it's pretty flexible and it's really designed to connect to other projects that are open source and have open APIs and other things like that. So I'm gonna walk you around the lab for a minute just to show you a little bit about what we do, because that's the easiest. So let's do that, and then I'm going to walk you through a use case where we're working with the Real Food Campaign and the Bionutrient Food Association, and how they use our platform to do the things that they want to do. So let's take a walk. See how well this works. Walking with the computer, but it's better than nothing. So so first thing that we do is for the Real Food Campaign, they're interested in understanding the connections between soil quality, food quality, and human health. And to help support them in doing that, we designed a little device, which is this thing, which is a reflectometer. Basically, it's like a colorimeter, 10-channel colorimeter. Flashes lights at a sample, and it's really designed to help establish correlations between hard-to-measure lab measurements about nutrition, like antioxidants and polyphenols and stuff like that, or hard-to-measure soil parameters like soil carbon, with easy-to-measure spectrometry, so the data that comes off of that. And if we can build a correlation between those 2 things, then we can build models and we can predict complicated, expensive lab stuff using simple handheld tools. So that's the idea. So we're actually in the process of shipping a bunch of these things. So here's all the boxes. There's a whole calibration process associated with this. So we actually literally take the instruments, where are they? There they are. And we put them in the oven to calibrate them by temperature. We also calibrate them all to each other using calibration cards to make sure that when we measure this thing on every device, it always shows the same output. So that, and again, this isn't just a nice idea, but if you want comparability between across many projects and many people across countries, you need to make sure that everyone's device says the same thing all the time. If we don't have comparability, then it's really hard to build an open ag tech space in software or in hardware. So that's the hardware piece, but we really want to focus on the software piece. So I'm just going to walk you through what we actually do to use the software in the Real Food campaign. Cool. So again, we're in a lab. You can see we have lab. We do a lot of lab intake stuff. So like when samples come in, they come onto here. Soil samples get air dried. There's a very specific process they have to go through. Then they get prepared for measuring soil carbon in the oven. They also get prepared for measuring minerals using the Xrf. So this is you can see it, the Xrf setup. That takes 3 separate steps. The Xrf is a proprietary tool, and so it saves the data actually in this totally stupid format that we have to paste into a Google Doc. So kind of classic, very manual lab processes. Yes, exactly. Totally stupid format TM. Thank you, Don Blair. So many of them. We do a lot of work with a scale, like everyone does. So we have to take a lot of measurements on a scale, and that's a lot of room for human error. We have a lot of glassware and all that kind of jazz. We take measurements in little cuvettes. There's some little cuvettes. Yeah, familiar with these? Lots of cuvettes. Color changey things, like antioxidants is a color change in the purple. So probably stuff, if you're familiar with labs, that you would see in other labs. So we measure antioxidants, polyphenols, minerals, total carbon, mineralizable carbon on the soils, XRF, all kinds of stuff. And of course, each of those measurements has its own standard operating procedure and also sub-measurements. So for example, antioxidants, you have to measure the color change in the cuvette at the very end of the process, but you also actually have to weigh the sample when it's wet, and then you have to weigh the sample when it's dry, and you have to subtract the two to get the, none of these things are just a one-stop type deal. So I'm just going to give you an example. How do we manage this whole data process using the Our-Sci platform? Because it's complicated and it's unique, and it requires a lot of different types of inputs from humans and from devices. So let's take an example. This is going to be a little awkward, but I'll do my best. I'm just going to try to point you at the screen while I do this, because there's no really other better way to do it. So we'll see if this works. Can you kind of see that, Dorn?
I can see it.
Okay, I'll do my best. So let's say like a carrot sample comes in. The first thing that we would run is a intake form. So that would be sample collection survey. And this asks information about when it was collected, the location of the sample, all the kind of things you would expect. The state and the county, so that if we wanted to anonymize up to the county level that we can. What kind of vegetable is it, all that kind of stuff. You can see all the questions. If you click on this, it actually shows you all the questions. So you can go down and look at it. So that's the intake survey, right? So it starts with a sample ID. We want all the sample IDs to connect. So now let's say it was a carrot sample. Once it came into the lab and the person in the lab actually wants to run it, we have a carrot quality survey. So at this point, they're going to want us to start the SOP for actually chopping up the carrot and measuring antioxidants and polyphenols. So again, first thing we do is a sample ID. If we want to scan the QR code, we can. This has a QR code scanner. And then we're going to, ask questions about quality, make sure we have the right type of sample. You can remember answers so that you don't have to do this 100 times. Any other metadata, like what color is the carrot? If you're trying to do analysis at the end, purple carrots might really throw you off, depending on what your goal is. Size of the carrot. Okay, so here's an example where we actually want to scan the carrot using a device. So we're just going to connect to a device. So this is where what we do is a little bit different than a standard survey platform. So we can actually connect to this reflectometer, I think you saw here, which is the one we've been using in the lab. This is connecting over Bluetooth, but actually you could also connect over USB serial. So we did it, run the measurement, flashy, flashy, flashy. And then it outputs some values. All right, so it tells us a lot of stuff. Like in this case, we actually didn't necessarily need this, but if we had run a blank, like if we were doing a cuvette and we wanted to run a blank, you can run a blank and it'll automatically subtract the blank on the next measurement, for example. It provides you estimates if it's polyphenols or antioxidants. This isn't, but it still gives you the estimates. Gives you all the raw spectral values from 365 nanometers up to 940. Those are all the LEDs that we run. There's 10 points in there. And then it gives you a bunch of raw values and standard deviations and all kinds of detailed stuff people don't want for the most part, and then environmental conditions. So I'm showing you this because this entire thing was actually is user definable. So I wrote this particular script, but this is a measurement script. You could make it do whatever you want. You could send the device, 1010, and you could get the device to send you back something, and you can interpret it all here however you wanted and display whatever you want to the user. So that's a key piece of the sort of flexibility that we'll show later. Again, if we were to run it again, create the carrot. Here's my favorite one because everyone has one of these. So we're going to get a weight. So this is no longer from our own little device, because then you'd be like, oh, Greg, you cheated because you made the device and you made the software. It's like, yeah, that's true. But what about a scale that has, wait a second, where is it? There we go. Scale, regular old scale, right? So we've got it connected via RS-232 in the back, which goes to USB and connects to our little Android app here. And if I say get weight, and then I press print on the scale, maybe. Oh, what did I do? Is it not plugged in or something? Oh, I know. Wait. I have to connect to it. Sorry. There we go. Don says this technology doesn't scale. I don't.
Oh, that's funny.
It does scale, Don. Watch this. Blammo! Take that. So it tells us what it is. It tells us the weight. As long as it's a scale that has a USB out or an RS-232 out, we can absolutely connect to it. That's what those are designed to do. And of course, you can take that information, and because you're writing just a script, you can connect it with information previous. So maybe you had a wet weight from before and a dry weight, and then you wanted to calculate the difference. You could just do that in the script, and you could output it to the user in real time. And if something was out of whack, like the answer was 1,000 and it should have been 1, you could tell them, hey, you probably screwed something up, go back and fix it. So again, this is just giving you a sense of how this works. And so I think that's given you enough of an idea. But what I want to show is just that all of these forms, we actually have to connect them together at the end by ID, right? We have a collection survey. Oh, shoot, Greg. Collection survey, a carrot survey, and a soil survey. And they all have to get connected at the end by the ID, which we then do. So hopefully that gives you a sense of kind of what the platform does. It allows you to collect data from a wide range of sources in a flexible way that allows you to error check, and then push it to one location where you can connect it together however you want. And that's the next step that I'll show you that I don't need to walk around the lab anymore for, but I will share my screen. One sec. So we've gone and we've collected all that data, which we have a lot of. And we can go to the website and look at it. So let's take an example like the carrot survey. Are you seeing my screen?
Yep.
Cool. So here's the carrot survey. We could look at, we could look at all the data, and that's all fine and dandy. You could download it as a CSV because scientists like CSVs. And, but I think what's more interesting is we can then connect all of our data together. So how do we do that? We use that same kind of strategy where we allow users to create JavaScript scripts and access stuff in the database, the surveys they created, and then do stuff with them. So let's go look at one. So this is an example script that takes all of those. There's actually because we versioned them, there is a total of, it's absurd, like 20 different surveys that we had to combine over the course of the last year by device ID, or by input ID. And using some JavaScript and a little bit of, graphing libraries and stuff like that, we can load them all up, merge them, clean them, just like you would do in R or Python, and then display them in real time to the user. Takes a minute because there's a decent amount of stuff, and there's a lot of calculation in there. And then when I'm done showing you this, I'll kind of show you the developer interface to be able to make that stuff happen. It'll get there. Unless Manuel's working on it right now. Okay. So now this is cool because it shows us all the information about not just the carrot survey, not just the spinach survey, but all of the surveys combined and the relevant information. So it shows us where all the surveys came from in this nice little map. Shows us the total number of surveys, when they were taken. So this is sort of a graph over time of when those surveys got submitted. And then I think this is the critical piece. So if you try to download the raw data, it's of course like a complete and utter mess. And what you want to send to the person doing the analysis is the cleaned up nice version. This is the cleaned up nice version, and it's all cleaned up in JavaScript. And then also we have the variable names and descriptions. And again, this output was produced using a JavaScript script. And then we have all the raw stuff. And then, of course, I've used this page as like the location where I send people who want to look at our data. So I don't have to send them unending piles of Excel spreadsheets which get out of date after a week because I found something was wrong or whatever. Like, this is always up to date. I know what it is. It's a single link. It gets better over time as I improve it. So here's all the definition of terms for everything that's in our database. And then we just do some basic, again, you always start with just descriptive. So, histograms for some of the key measurements like soil respiration, organic matter, polyphenols in carrots, protein in carrots, antioxidants. Just this alone is interesting. Antioxidants in carrots bought from the grocery store or from farms ranges from basically 0 to 250. So a carrot is not a carrot is not a carrot in terms of antioxidants, that's for sure. And polyphenols is kind of the same story. Anyway, we can, whatever kind of graphing library you want to use, you can throw in here. It's just vanilla JavaScript, so if you want to pull it in, you can. And then we try to, do some other graphing, trying to relate different parameters together. And then this is all of our spectral data from the device that I was showing you before, just showing spectra from different carrots. Probably like this is purple carrot, and this is orange carrot, and this is yellow carrot. That's my guess. But okay, so that's the basic structure. We have a flexible intake we have a database to store it, and then we have a flexible display structure in the dashboards. Those are the sort of key components of the system. So let's see, just spend like 5 minutes diving into what the backend stuff looks like. So what do we use for that? In our previous project, PhotoSync, we sort of built all of these interface components from scratch. And the lesson learned from that is, unless you want to manage an immense amount of code in a bunch of different languages, don't do that. So this time, our strategy was to use existing applications to provide a space for developers to create the content they want to create without us having an immense amount of development overhead to maintain those creative spaces for them. So we use VS Code, which is just a IDE, or like a kind of a lightweight coding program that's available on all platforms, in order to build out and test a new script. For example, if I'm testing a script that I'm sending to one of our devices or to a scale like you saw before, but also to build our dashboard, right? And because everything's in JavaScript, it's basically the same thing. You're just running JavaScript code, and you can do it here. So let me show you an example one. So this is a script that we use to communicate with one of the spectrometers, or one of the devices that I showed you before. So I'm plugging in the device over USB, turning it on. Okay, so my device is on, sitting here. And so now the question is, if I want to develop a script for this device, I can't just write a bunch of code and iterate without connecting to the device, right? Like I have to connect to the device in real time and get real-time feedback to make effective code to talk to this thing, or else it's going to be a slow, painful process. So, so what we do is we can actually start a dev server right here in VS Code, and then we can, from that dev server, open up a web browser, which I'll show you in a minute. So open up a web browser. Bloop. And now that web browser is connected sort of in real time to the scripting code that we're working on over here. So now watch what I can do. And if you're a normal person, you're like, who cares? And if you're a developer, you're probably like, oh, that's useful. But let's say I wanted to run this code. All right. So I can just hit run sensor. All right. So it sends the data out to the sensor. Hopefully flashy, flashy. Here we go. So from VS Code, I just talked to a USB connected device. And then that USB connected device sent data back to my computer, got interpreted by VS Code in JavaScript that I'm debugging in real time, and displayed it in a web browser. So now I can just iterate the crap out of this thing, right? Like that's how you develop, iterate quickly. So it shows me all the stuff. So now if I say, oh, you know what, I actually want to change this device ID, or I want to change the reflectometer, or I want to adjust some of these values, or I want to go back into a library and improve how I'm doing my averaging here or something, boom, I just go modify it here, I press run sensor, and poof, I get the output right here. So now I'm able to iterate and develop. So I think this is one of the key pieces. Say that's super. Thank you, Don. I use it like 4 hours a day, every day. So, this is one of the pieces that I hope helps us be a good open ag tech tool, because it provides a layer of like high flexibility without requiring you to be like a full stack developer, right? Like you can know JavaScript and fool around and iterate quickly and get something going, and then push it and 1,000 people around the world can use it right then and there in a comparable way. That's really our goal. So there's your measurement script side. So now let's take this is my last 5 minutes. So I'm now going to give you an example where we do the exact same idea, but now we're going to do it on the dashboard side. So again, just using VS Code. Let me close this guy out. So now, of course, in a dashboard, because we want to run that on the web, we're not connecting to a device here. We're actually just taking a bunch of data and then doing stuff with it, right? So here's all the surveys. Remember I said there was like 20 surveys that we had to combine on sample ID? Here's all those surveys. You know, we cleaned them up. So much nonsense in here because we did so much wrong. So we cleaned it up. We sanitized the numbers so that, you know, our graphs don't break. Like all the crap you have to do to get basic graphing to work. So it's all done in here. We combine them all, join them, make one final survey, create that button that says download CSV, like all that kind of stuff. This looks complicated, and it is because this is a fairly complicated dashboard. It does not have to be that complicated. You could make an interesting dashboard on some basic data in all of 20 lines. It's not that complicated. And we are in the process of building out a library so that basic functions like joining, for example, joining two things on a single ID becomes a single line of code rather than everybody having to build that function themselves. So let's just run this real quick. Hopefully I got this right. I don't. What is it? Here we go. So here, instead of like running the sensor and stuff, we just open with live server. Starts the server, opens the dashboard, runs the JavaScript exactly like it did on the web. And we can iterate in real time, just like we did in the case of our device, and build ourselves a dashboard, push it to the web, and everybody can see it. So those are the back-end pieces to make the front end easy. It's really just it's in the world where I create every UI piece you could ever want and imagine, which takes me 10 years, but gives you a simple experience over here, to you have to code everything yourself and be a full stack developer to get things done over here. We picked what we felt was a reasonable middle point, where if you can code in JavaScript, you can do 99% of what you need to do. And for all other users, they have a pretty straightforward and easy user experience. So yeah, in a nutshell, that's the Our-Sci platform.
Thanks, Greg. That's terrific, and I think sets a good template for others to follow as we're sharing, to look again, provide some insight into what we're doing on a day-to-day basis, and find cross-pollination. So we're also trying to ask sort of 3 standard questions for folks so we can sort of build on around open ag tech. And then if you have time, I know you have to head out pretty quickly. Others folks from the Goat community can add some additional questions. But first is just, why did you choose open source, and how have you found that's helped or hindered? What are the challenges, and what are the benefits?
So I got focused on open source probably 10 or 12 years ago when I was in the biodiesel community, actually with you. We were sort of in the same community at the time. People, early biodiesel people in the United States at least, were a super fun, crazy, shared everything, talked about everything, learn stuff in your garage, scale it to 1 million gallon kind of group. And that was just so wonderful that when I realized that the world didn't work like that, I was quite frustrated. So I'm just an open tech advocate for that reason, because I've seen it be really great and fun, and more things should be. So.
And from that perspective, you know, how does how does your current model sort of work with that open model from a publishing perspective, business perspective, interaction with nonprofits and so forth.
Right. Well, the downside of open source we're a business, so an LLC. We did that mostly because it's the simplest and most straightforward and least overhead organizational structure in the United States. So it just felt easy. But the downside to open source is it's really hard to get investment. Investors of any type want to see intellectual property. They want to see some level of control of a market. Every once in a while, you find one who is a bit more nuanced, but not most of the time. So you have to bootstrap. So that's a downside. But there's a ton of upsides that I think are way underappreciated. One upside, I think, is that by making everything public, you build a big user base and developer base, even if they're not actively contributing. You get your name out way faster than a normal company would with very little resources. I think in that same way, if you're creating something new, you establish yourself centrally in the development space so that even if everything is public, your name and your experience becomes the driver for business more than anything else. I think that's been true for us as well. And then finally, if you're first to market, I think being first to market is helpful in open source. If you are first to market, you make competition like next to really, really hard. If you're first to market and you're open source and you have a reasonable product, competing with you just for the most part doesn't make sense. And if someone tries, if they're a for-profit closed source company, they're going to have to justify to investors why someone's going to use their expensive thing that they need a 10-to-1 return on as compared to the free thing that's already out there. So, yeah.
And do you have, I'm always interested in sort of, especially as we get into health and climate and these issues, sort of the importance of trust and integrity of the science. So I think especially when people are sort of often skeptical of science and studies that are coming out, I imagine that plays into the kind of work that you're doing and how important it is to be really transparent.
Yeah, and that should be a bigger argument, and I think it is, but I feel like only when you push it.
Mm-hmm.
Because the sort of like ether is that companies have to have proprietary stuff, and no matter what you're doing, someone's going to have it, and people just accept it even in areas where it's absurd. And it's really our job to come into those spaces and say, hey, no, this is not the norm. It doesn't have to be the norm. You don't have to accept this. As the person asking for the work, as the customer, like you should be expecting more. And I think as we and in other spaces, other people have expressed that, customers have started to demand, like the U.S. government, among others, that open be part of what they expect from people that are building their software hardware, which is great.
And finally, sort of our standard question is, what does your ideal agricultural future look like?
I don't know. Do you answer that question 200 years down the road, 100 down the years road? Like, I just finished watching The Expanse, so I'm like,
And the future is a really long time, so.
Yeah, it's a moment. Yeah, I mean, my hope is that open source business models, win out. And not only business models, but I'm sure that even that term itself will become irrelevant in the next 75 years as our productivity shifts towards automated processes and we move towards universal basic income, or however we end up addressing those things. Like our whole idea about how we use our time and when and why. Yeah, exactly. Ganymede agriculture, exactly. The shift, like it's going to be completely different. So, I hope that the tech that we use in agriculture, which is so central to keeping humans alive, is public. So, yeah.
Great. And I'll open it up for other folks on the other members of the goat herd who are joining here today. If you just if you have a question, just let us know who you are and ask away. We've just got a couple more minutes, I think, before Greg has to go pick up kids.
But yeah, 3:10. 3:10.
Okay.
Yeah. Where do we go online to get started hacking with this lovely system? That's a good question. You could go to Git Lab and search for Our-Sci, O-U-R-S-C-I. And you will find all the repos. So you'll probably need a little, something we want to work on this year is to make that interaction easier. But you'll probably need maybe a 20-minute intro to like how to use repo and all that kind of stuff. Yes, there are Hello World dashboards. Totally. Yep.
Who are those questions coming from?
Sorry, Don Blair.
Don Blair. Okay.
We could report. You guys should just use your words. Like you can talk. This.
Yeah.
Yeah.
Come on, guys. Don't be shy.
Yes.
I got a burning question.
Great.
Yeah, I was just wondering when you're in VS Code there and you do run sensor,
yep.
I'm just curious the particulars. Like, what is that? Just like an npm script or something? Is that? Are you just like running? Are you running a particular? You're running that processing.js script when you do that? Is that?
Yeah, that's right. You run that. You run that. Actually, Manuel should be here because he's the one who, I play in the sandbox, but he builds the sandbox. I think I understand the sandbox. But basically, it runs a set of scripts in order. So it runs the sensor script, which talks to the sensor. Okay. And then once that's done, it passes the information into a file, all the data, whatever it is that you wanted from the sensor. And then it runs the processor script, which just takes that. And the reason that we split it up in that way is because you get the data from the sensor once in the field, right? But right. You may want to rerun that processor script, how you interpret that sensor data, multiple times. Like you may want to adjust that so that later on when somebody's looking at it on the web, you fix something,
Right.
So they're disconnected. It runs the sensor script, then the processor script. If you put the information on the web, it won't run the sensor script. It'll just take the sensor data and run the processor script again.
Very cool.
Yeah.
Very cool.
Greg, I have a question. This is Mike Stenta. What's the availability of those devices that you're making for BFA?
Yeah, they're well. Right now, you can only buy them through the BFA. We'll also send some to partners, Quick Carbon, and then. But we probably should just sell them through our website. But we don't have that set up yet. But yeah, we should. We made more than the BFA will buy, so we do actually have extra ones. But,
follow-up question, and I don't know if you mentioned this already, but all of the hardware specs for that is open source as well, correct?
Correct. Yeah, and it's at the Our-Sci Git Lab page as well. Yep. There's the firmware, and there's the the circuit board was designed in KiCad, which is a free and open source software for circuit design. And then I believe there's a link to it, though it's not in GitLab. The actual case was designed in a program called Onshape, which is a 3D modeling tool that's web-based, which is not open source, but is web-based. So.
Cool. Thanks.
Yeah.
Greg, I have another quick question. What tools are you using for documentation, and also what licenses open source licenses are you using?
We use GPL version 3 whenever possible. Sometimes there's libraries that we're using that restrict the end license. So we're probably applying the wrong license to some things based on what libraries we're using in that code, especially because we use NPM a lot.
Mm-hmm.
But yeah, GPL version 3 for the most part. And then in terms of documentation, been working on that. So we now have docs.our-sci.net. And we have walkthrough for the device and stuff in here, but we're going to try to put more on here. And this is actually all maintained on our Git Lab page. You guys are probably familiar with this. I think other people use it too. So you can create documentation on a wiki. So we have a documentation GitLab page, and then we just populate the wiki just like you would normally. And then, again, Manuel would know this, but basically he can just mirror the wiki on our own page, docs.our-sci.net, in this format. So that's what we've been starting to do with documentation. And for our customers who use the products that we develop, like the bionutrient sensor, we make a specific version for them, and then they can just forward that using, their forwarding address. So for example, they have a bunch of experiments that they run which are non-standard. They're not like what we would do necessarily with a device. So we have a home page which includes their experiments and all that kind of detail that they would need. So, yeah.
Right. I had another quick follow-up, which is, what other Goat projects are you currently intersecting with, and then how would other projects within the community reach out to you to create those, to work with you on developing APIs, et cetera?
Sure. So, well, we're working with FarmOS, or we will be pretty soon at least. We have already a little, but we'll hopefully do that more. Primarily on farm use cases, which are very research focused, where there's lots of farms contributing to a single research project. So basically, use cases where users are having to input non-standard, complex data that a normal farm wouldn't experience, and therefore it doesn't make sense to build specific stuff in FarmOS around. So we kind of act as like the mobile experience for people collecting farm data, as well as other types of more complex data, to push into appropriate buckets in FarmOS. So that's one big piece. Let's see. I think we just got an email from Jane, actually. And Dennis, a collaborator with Dennis Buckmaster at Purdue, has 2 students available for 10 hours a week engineering time. And Jane and I have been trying to initiate this single pixel camera project, which is totally separate from all this. And I think we're going to get some student engineering time on that, which is great. So that's exciting. And then, of course, we're working with you, Dorn, on the FAR project. And hopefully we're going to work with Ankit on that project as well. It's probably not everything. But.
Well, and I'll just mention that this is online, but there's I'm going to put somebody at MIT who's working on a low-cost Rhizotron mechanism. They'll be in touch with you too, which will also be on the lookout for that.
Oh, cool.
Yeah.
Well, also Dan Kane and Quick Carbon, which he didn't go to the GOAT conference, but he's definitely in the mix.
Oh yeah, for sure.
So we're building out like a better user experience for people to be able to go to a field. It's going to be so cool. Like, you go to a field, you lay out the field. Like, when you're there, you say, here's the corners of the field. You press go. It automatically gets all the maps for terrain, like altitude changes, and also soil maps. And then it clusters sampling sites for doing soil carbon sampling. Then you go around, you measure soil carbon with one of these devices, and then it gives you a real-time map of soil carbon in your field. So that's going to be great. I think we'll do that this year sometime, probably in the first 8 months.
And we'll probably get some of those folks on as part of the speaker series, so we can dive in deeper on some of those pieces as well.
Especially do it more towards the end of the year, because they're doing a lot of the background work this year to build confidence so that when you go out and do that, we can give confidence estimates on, what your soil carbon numbers are. So it's a neat project.
Absolutely. Other questions from the herd?
I'll ask this. So in terms of like the core focus of what we do, like what are the things that you think we should be doing that we're not? Or who should we be connecting with that we're not in the OpenAg community? I'm curious.
Well, I'll say part of what I think it's already part of the plan, but I'm excited about the linkage between the Quick Carbon project, Our-Sci, and the Land Potential Knowledge System interface, which adds additional environmental observational data that can be collected at the same time and has some additional field protocols. And I'm particularly excited about the linkage of the hardware with some of the projects like the microbiometer out there, even though it's sort of, I would love to get them on this series too and see where they're at.
Definitely. Yeah. I'd love to see more of the people working on like in-field robots and stuff too.
Oh, exactly. Yep. Yeah. Sort of equipment mounted sensor and automated sampling. I think that's a great great point. There's some folks working on just such a system in Germany that we've just spoken with that maybe we could get them on as well.
Cool.
Great. Well, thanks everybody for joining on this first one. And Greg, we're going to let you head out and pick up your kids, and then we're going to also this group is also going to do a little bit of work offline after this to get ready for building the next series and looking at how we can host this well going into the future. So the general plan for folks tuning in is that we'll be having these sessions every 3 weeks or so and expanding and updating, and we'll loop back with folks who have presented before, but we want to get a really good diverse mix and representative folks on the call for asking questions and also presenting. So we'll be posting sort of a sign-up sheet, but also if you're interested, please join the forum, post that you're interested, or get on the Riot chat and let us know that you'd like to present, and we'll make it happen. So thanks everybody, and we'll see you all again soon.
Thanks.
Say bye.
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 Bye.